Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter work, power and energy. So any doubts you have, please write that in the comments section. And please install our Sapience Education application where we shall upload some important questions based on previous year JEE Mains exam, which shall be helpful for your exam. So here it is told that a force F equals to 2 plus 3x I cap. It is acting only along the x-axis, where F is in Newton, x is in meter. The work done by this force during a displacement from x equal to 0 to x equal to 4 meter is. So the work done that is equal to, we know that it is uh, integral f dot dr from r initial vector to r final vector. So now here it is acting only along x-axis. So I will say that it is equal to f dx integral from 0 to 4. Since here x initial is 0, final x is 4 meter. So this will be equal to integral 2 plus 3x dx from 0 to 4. This will be integral will be 2x plus 3x square by 2, and that will go from 0 to 4. This will be, so now this will be equal to 2 into 4 plus 3 by 2 into 4 square minus 0. So this will be 2 4s are 8, 8 plus 2 8s are 16, 3 8s are 24. 24 plus 8, that is equal to 32 joule. So the work done is 32 joule. Then here it is told, if the maximum load carried by an elevator is 1400 kg, 600 kg uh, passengers plus 800 kg elevator, which is moving up with a uniform speed of 3 meter per second, and the frictional force acting on it is 2000 Newton, then the maximum power used by the motor is. So the elevator that is going up with a uniform speed, and its weight is, its mass is 1400 kg. So the weight acting downwards is mg, and frictional force is also acting vertically downwards since it is going upwards. So therefore the net force applied by the motor, the net applied force by the motor is frictional force plus the weight. G we have to use 10. So this will be, so F will be equal to 2000 plus 1400 into 10. This will be 14,000 plus 2000, that is 16,000 Newton. So 16,000 Newton is the force applied by the motor. Therefore, the maximum power supplied, the power supplied by the motor, power supplied by the motor, that is equal to force into velocity. Here it is going upwards with uniform speed, that is 3 meter per second. So it will be 16,000 into 3 watt. So it is 48 kilowatt. So 48 kilowatt. So 48 is the answer. Then here it is told, a closed circular tube of average radius 15 centimeter, whose inner walls are rough, scaped in a vertical plane. A block of mass 1 kg just fit inside the tube. The speed of the block is 22 meter per second when it is introduced at the top of the tube. After completing 5 oscillations, the block stops at the bottom region of the tube. the work done by the tube on the block is. So here, as you can see that work done by all forces equals to change in kinetic energy, you can say. So now the work done, that is so here the block will stop after completing 5 oscillations. So this is V equal to 0. Means work done by the tube on the block, which is the frictional force, the work done by the frictional force, plus work done by the normal reaction force, plus work done by gravity. So these are the forces acting on it. That should be equal to change in kinetic energy, which is half mv square minus half mu square. So the final kinetic energy is 0 only, and work done by the tube, that has to be found, plus work done by the normal reaction will be obviously 0 only, plus work done by gravity, that is mgh, is mg into h, which is equal to minus half mu square. Therefore, work done by the tube on the block equal to minus mgh plus half mu square. So you have to find the only the magnitude of the work done by the tube on the block, which is the work done by frictional force. That should be obviously negative only. This value you have to find. M is 1 kg, G is 10, height, the initial height from the bottom region of the tube, height from the bottom region of the tube, h, that is equal to 30 centimeters, which means it is 0.3 meters. 0.3 plus half mu square. M is 1 kg, and u is 22 square. This will be 3 plus half into 22 into 22, 2 11s are 22. So this will be equal to T plus 11 to the 22, 11 to the 2 plus 2, that is 242. So it is 245. So 245 joule is the work done by the tube on the block. Then here it is told body of mass 5 kg is moving with a momentum of 10 kg meter per second. A body is there, its mass is 5 kg. Mass is 5 kg. It is moving with a momentum p, which is mv. So that is 10 kg meter per second. So hence it means the, okay, now a force of 2 Newton acts. A force of 2 Newton acts on the body in the direction of its motion for 5 seconds. Then the increase in the kinetic energy of the body is. So we can say that the change in momentum, that is equal to the force into the time in interval for which the force is acting. So therefore I can say P final. So here you have to find the increase in the kinetic energy of the body. So it means P final minus P initial, that is equal to, so this is the P initial mu, that is 10 kg meter per second. P final minus P initial is F delta T. Now P final means it is mv that we have to find, that is equal to mu plus F. Okay. Okay, so V that will be equal to U plus F by M into delta T. So V that is equal to U. So 5U that is equal to 10. So U equal to 2 meter per second. 2 plus F. F is equal to 2 Newton. 2 by M. M is 5 kg and into delta T. So it is acting for 5 seconds. Force is acting for 5 seconds. That means 2 plus 2, that is 4 meter per second. So the final velocity is 4 meter per second and initial velocity is 2 meter per second. So therefore the initial kinetic energy that is equal to, so the initial kinetic energy is equal to half mu square, that is equal to half into 5 into u 2 square. So that is 2 to the 4, 2 5 is the 10 joule. And the final kinetic energy that will be equal to half mv square. So that is half into m, that is 5 into v square, v is 4. So 2 8 is 16, 5 8 is 40 joule. So therefore the increase in the kinetic energy that will be equal to kinetic energy final minus kinetic energy initial. So that is equal to 30 joule. So 30 joule is the answer. Then here it is told a body is dropped on the ground from a height h1. A body is dropped on the ground from a height h1. After hitting the ground, it rebounds to a height h2. If the ratio of the velocities of the body just before and after hitting the ground is 4, the ratio of the velocities, okay, the ratio of the velocities just before hitting the ground and after hitting the ground is 4, then the percentage loss of kinetic energy of the body is x by 4. The value of x is, so it means that just before hitting the ground, it's, if its velocity is 4v, then after hitting the ground it should be v, and the percentage loss in kinetic energy is x by 4. Percentage loss in kinetic energy, that is equal to x by 4. Then the value of x we have to find out. So 4v, that is equal to, actually v equal to, let's say with v1 it will hit and with v2 it will, so v2 is the velocity with which it will be after hitting the ground. So we can say V1 equals to V1 square, that is equal to 0 square plus 2GH1, and V2 that will be equal to means U minus GT. Or you can say V square, which is 0 square equal to U square minus 2GH2. So it means V2 square equal to 2GH2 and V1 square equal to 2GH1. So their ratio, that is V1 by V2, so it is equal V1 by V2, so that is root 2 GH by root over 2 GH2, so that is root over H1 by H2, and that is given as 4. So therefore H1 by H2 that is equal to 16. So H1 equal to 16 H2. So then here it is told the percentage loss in kinetic energy. Percentage loss in kinetic energy, that is equal to KI minus KEF. So the percentage loss in kinetic energy, that is kinetic energy initial minus kinetic energy final by kinetic energy initial into 100%. So that is equal to x by 4. The value of x has been asked. So now kinetic energy initial, that is equal to half m v1 square. Now half m v1 square, that is equal to mgh1. Initial kinetic energy is half m v1 square minus half m v2 square by half m v1 square into 100%, which is equal to x by 4%. So therefore m by 2 I can cancel out. So this is 1 minus v2 square by v1 square, that is equal to x by 400. So x by 400, that is equal to 1 minus v2 by v1. v2 is v2 by v1, that is equal to 1 by 4. v2 by v1, that is equal to 1 by 4. So this is 1 by 4 whole square. So therefore now x by 400, that is equal to, for 16 minus 1, that is 15 by 16. So x will be equal to 15 by 16 into 400, which is 4 hundreds of 4 4 16, 4 25 is 100. So x will be equal to 15 into 25, which is 15 5 is 75, 375. So the percentage loss in kinetic energy of the body is 375 by 4%. So the answer is 374. No, 375, sorry. 375 is the answer. Then here it is told a particle of mass 10 gram moves in a straight line. A particle of mass 10 gram moves in a straight line with retardation 2x. So retardation, that is 2x. So it means acceleration is minus 2x, where x is the displacement in SI units. The loss of kinetic energy for above displacement is 10 by x power minus n joule. The value of n will be with retardation. Okay, so therefore, note that work done by all forces equal to change in kinetic energy. So therefore now retardation is there, so obviously there will be a loss in kinetic energy, that is equal to work done by the retarding force, work done by the retarding force. Work done by the retarding force, retardation is 2x. So therefore the force that will be equal to mass into acceleration. Mass is 10 grams, so it is 0.01 kg. So it is 0.01 into 2x, that is 0.02x Newton. 0.02x Newton is a force. So force is a function of x. Force is depending on x. So here we need to do the integral. So it will be f into dx. Is 0.02 x dx from 0 to x. So this will be 0.02 into this is x square by 2, and it will go from 0 to x. So this will be 0.02 into x square by 2 only. Square 0.01. So this will be 0.01 x square, or I can say it is x square by 100, or I can say it is x square by 10 square, or I can say it is 10 by x power minus 2. Since it is x by 10 power 2, or so it is x by 10 by x power minus 2. So this value of n will be 2 here. The value of n will be 2 here. And here it is told a block is fastened to a horizontal spring. Block is here it is told a block is fastened to a horizontal spring. The block is pulled to a distance x equal to 10 centimeter from its equilibrium position at x equal to 0. So the equilibrium position is x equal to 0 on a frictionless surface from rest. So here there is frictionless mu equal to 0, so it is smooth surface. It is brought from rest, means u equal to 0 only. Brought only frictionless surface. So from here to here there is no friction. The energy of the block at x equal to 5 centimeter is 0.25 joule. So the spring constant of the spring has been asked. So it is fastened to a horizontal spring. The spring is okay. The energy of the block at x equal to 5 centimeter. Actually, what is happening initially? It's fastened to a horizontal spring. It is brought from here, sorry, 0 from its equilibrium position at x equal to 0 to till here. Here it is brought till x equal to 10 centimeter. The energy of the block at 5 centimeter. When it is at x equal to 5 centimeter, the energy is 0.25 joule. The spring constant of the spring we have to find. K we have to find. So here, the velocity will be 0. Here also initial velocity is 0 only. But here it will have some energy. So here we will also say work done by all forces equal to change in kinetic energy. So from the energy means the total energy. Total energy, that is sum of the kinetic energy of the block plus the potential energy of the spring. So that is 0.25 joule at x equal to 5 centimeter. And here it is coming to rest. So therefore I can say here the kinetic energy is 0 only. So potential energy of the spring, that is equal to 0.25 joule at x equal to 10 centimeter. So therefore I can say half kx square. Half kx square means 5 by 100 square, that is equal to 0.25. So therefore we can say k into 5 by 100, so 1 by 20, so it is k by 2. K by 2 into 200 square, that is 400, that is equal to 0.25 means 1 by 4. So 400s are 400, so K will be equal to 200. 200 Newton per meter is the spring constant. Since here there are no non-conservative forces, so we can apply the rule of conservation of me mechanical energy. Conservation of mechanical energy concept, we can use it here. So the spring constant is 200 Newton per meter, which is the answer. And here it is told a force F, which is 5 plus 3y square, acts on a particle in the y direction where F is in Newton, y is in meter. The work done by the force during a displacement from y equal to 2 meter to y equal to 5 meter is the work done by the force during the displacement. So here F is not constant, so I can say work done will be integral Fy dy, Fy dy from y initial to y final. Now y initial is 2 meter and y final is 5 meter. So therefore the work done by the force, that will be equal to F, that is 5 plus 3y square dy integral from 2 to 5. So this will be 5y plus 3y square dy, so y cube by 3, so this is y cube, and it will go from 2 to 5. So this will be 5 into 5, 5 5 is 25 plus 25 plus 5, 125 minus 2 5 is 10, 10 plus 8. So this will be 150 minus 18. That will be equal to 50 minus 20, that is equal to 130. So that is, this is 132 joule. So 132 joule is the work done. 32 joule. And here it is told a small particle moves to position 5 I cap minus 2 j cap plus k cap from its initial position 2 I cap plus 3 j cap minus 4 k cap under the action of the force 5 I cap plus 2 j cap plus 7 k cap Newton. The value of work done will be, so work done we know that is equal to, so here force is constant, so we can say F dot S, work done will be equal to F dot S. Now S is equal to the displacement, that is equal to delta R vector, which is R final vector minus R initial vector. It means the final position vector minus initial position vector. Final position vector minus initial position vector. So here it is told that the final position, final position is 5 I cap plus minus 2 j cap plus k cap, and the initial position is 2 I cap plus 3 j cap minus 4 k cap. So therefore the displacement, that is equal to R final minus R initial. So if you subtract these two, then we will get 3 I cap minus 5 j cap plus 5 k cap, this much meters. Now F vector, that is 5 I cap plus 2 j cap plus 7 k cap Newton. So therefore the work done, that will be equal to F dot S. So 3 5s are 15 plus 2 into minus 5, that is minus 10, plus 7 5 is 35. So now, so it means 35 plus 5 we have to do. 35 plus 5, that will be equal to 40 joule. The work done is 40 joule. So here it is told a lift of mass m equal to 500 kg is descending with a speed of uh, it is descending with a speed v of 2 meter per second. Its supporting cable uh, begins to slip, thus allowing it to fall with a constant acceleration of 2 meter per second square. The kinetic energy of the lift at the end of the fall the kinetic energy of lift at the end of the fall through to a distance of 6 meter will be 6 meter it will fall. Here we can say work done by gravity. Okay. Or we can say V is equal to U plus AT. It is descending with the speed. V equal to U plus AT. Or you can say V square equal to U square plus 2AS. Since here time is not told, here the distance is told. So V square, that will be equal to U square 2 square plus 2 into S. S is 6. So 4 plus 4 6 are 24. It is equal to 28. So V will be equal to 4 sevens are 28. So 2 root 7 meter per second. Two root 7 meter per second. So therefore the kinetic energy of lift at the end of the fall. So that is half mv square. So that is half into 500 into 28. So 14 2s are 28. So 7 into 1000. So that is 7000 joule. So it is 7 kilojoule. Body of mass 2 kg is initially at rest. Initially it is at rest. The mass of the body, that is 2 kg, it starts moving unidirectionally under the influence of a source of constant power P. Its displacement in 4 seconds is 1 by 3 alpha square root P meters. Its displacement in 4 seconds. So the power is constant means force into velocity is constant. So I can say P that is equal to m dv by dt into V. That means V dv that is equal to m P by m into dt. That means V square by 2 that is equal to P by m into T. So V square equal to 2P by m into T. Now, so V will be equal to root over 2P by m into root T. So B is dx by dt. So dx by dt is root over 2P by m into root T. So therefore dx that is equal to root over 2P by m into root T dt. Then we have to integrate it, x initial to x final from 0 to T. So x initial, x final minus x initial, that is the displacement s, that is equal to root over 2P by m into t power half dt. So that is t power 3 by 2, 0 to t. The displacement in 4 seconds. So the s that will be equal to root over 2P by m into so the mass is 2. So I can write 2P by 2 into, and t is 4. So 4 power 3 by 2, 0 to 4 that will be. That is root p into 2 power 2, so 2 power 3. So now this is 8. So 8 root p that is equal to 1 by 3 alpha square root p. So therefore alpha square that is equal to 24. Two kg root p. So root p integral that is t power half. Okay, t power half by 3 by 2. This will be 2 by 3. So okay, so 2 by 3 root p. Okay, so this will be 4. It is just 16. Okay, so this is 16 by 3 root p, that is alpha square by 3 root p. So alpha root p cancel, 3 will cancel. So alpha square equal to 16. So alpha will be equal to 4. So the correct answer is 4. Then it is told 0.4 kg mass takes 8 seconds to reach the ground when dropped from a certain height p above the surface of Earth. Uh, 0.4 kg mass takes 8 seconds to reach the ground when dropped from a certain height p above the surface of Earth. Mass m that is 0.4 kg. So it takes 8 seconds to reach the ground when dropped from a certain height p above the surface of Earth. 6 seconds. The loss of potential energy in the last second of the fall is. So the displacement in the 8th second, that is equal to u plus half a into 2n minus 1. That is 2 into 8 minus 1 s nth, the displacement in the nth second. So the displacement in the 8th second, that is u will be 0 only since it is dropped. So half into g is 10 into 2 into 8 minus 1. So this is 5 into, that is 16 minus 1, that is 15. 15 5 is 75 meters. So therefore, the loss of potential energy in the last second, that will be mg into s eighth. The mg into the displacement in the 8th second. So m is 0.4 kg, g is 10, and s nth is 75. This is 4 into 75. 4 5s are 20, 4 7 28, 300 joule. So the loss of potential energy in the last second is 300 joule. It is told here that an object of mass m initially at rest on a smooth horizontal plane starts m- moving under the action of force F equal to 2 Newton. In the process of its linear motion, the angle theta as shown in the figure between the direction of the force and the horizontal varies as kx theta equal to kx, where k is a constant and x is the distance covered by the object from its initial position. X is the distance covered by the object from its initial position. The expression of kinetic energy of the object will be E equal to n by k sine theta. The value of n is over the object. Yeah, so it is moving under the action of this force. Smooth horizontal surface. Motion. The constant x is the distance covered by the object. The expression kinetic energy. Okay, so as we know, change in kinetic energy that is equal to work done by all forces. So here work done by uh, uh, so work done by weight, that will be work done by mg, work done by gravity, that will be 0 only since it is the displacement is perpendicular to the weight. Therefore, work done by gravity plus work done by the force F, that is equal to change in kinetic energy, that is half, that is the E. It starts from rest, so the initial kinetic energy will be 0 only. So the final kinetic energy, it has been told, that is equal to n by k sine theta. So that we are, so here n we have to find out. So n by k sine theta, that is equal to work done by the force F. Work done by gravity will be 0. Work done by the force F, that is equal to that will be F cos theta into x. F cos theta into x. Since f sine theta, for f sine theta will do no work. And there is normal reaction also, that will also not do any work. So work done by normal reaction is also 0. Now friction is not there. Okay, so therefore n by k sine theta, that is equal to f, that is 2 Newton, 2x cos theta, so cos kx. Two x cos theta. So this is n by k, theta is kx, so n by k sine kx, that is equal to 2x cos kx. Two x cos kx only is the kinetic energy of the object. So n will be equal to 2kx cos kx by sine kx. Now, if I put x as 0, we can tell n will be equal to limit x tends to 0, 2kx cos kx by sine kx. We can apply limit also when x tends to 0. So then this will be limit x tends to 0 cos 2 cos kx divided by limit x tends to 0 sine kx by kx. So this will become 1 and this will be also 1. So it will be 2. So n will be equal to 2. So the value of n is 2. Here it is told a body of mass 1 kg begins to move under the action of a time dependent force F equal to T I cap plus 3t square j cap, where I cap and j cap are the unit vectors along the x and y axis. The power developed by above force at the time t equal to 2 seconds will be. So the power developed, the power developed, that will be equal to F dot V time 2 seconds. Yeah. So force, that is equal to mass into acceleration. Mass is 1 into A, that is equal to T I cap plus 3t square j cap. So acceleration is this much meter per second square. So now velocity you have to find V equal to integral A dt. One kg begins to move, so it is initially at rest. Actually, V minus U equal to integral A dt. So since U is 0, so we can say V will be equal to integral A dt from 0 to t. So this will be equal to integral T I cap plus 3t square j cap dt 0 to t. So this will be equal to t t dt, so it is t square by 2 I cap plus this is 3t squared, so t cube by 3 t square dt is t cube by 3, so this is t cube j cap, this much meter per second. This is the velocity at any time t. So now therefore the power developed, that will be equal to F dot V. So F dot product with V we have to do. So it will be t cube by 2 plus 3t square into t cube, that is 3t power 5. This much watt. So we have to find the power the power we have to find at time 2 seconds. So that will be equal to 2 seconds, so 2 cube by 3. It is 8 by 2 plus 3 into 2 power 5. That is 4 plus, what is the 32? 32 into 3. That is 96. So 96 plus 4, that is 100 watt. So 100 watt. Spherical body of mass 2 kg starting from rest acquires a kinetic energy of 10,000 joule at the end of 5th second. The force acted on the body is, a spherical body is there of mass 2 kg. It starts from rest equal to 0 and acquires a kinetic energy that is equal to 10,000 joule at the end of 5th second, at t equal to 5 second. The force acted on the body is, so as you know, work done by all forces equal to change in kinetic energy. So kinetic energy final minus kinetic energy initial. So initial kinetic energy is 0 only, since initial speed is 0, it starts from rest. The final kinetic energy is 10,000 joules. So force acted on the body is. So now that force into displacement, that is work done. Now now the velocity we can find final velocity. So half mv square, that is 10,000. M is 2. So v square into 2 by 2, that is equal to 10,000. So v is equal to 100 meter per second. The 5th second. So v equal to again u plus 80. So v, that is 100, that is u equal to 0 plus a into t. T is 5 seconds. So acceleration, that will be equal to 20 meter per second square. Now therefore the force acting, that will be equal to mass into acceleration. Mass is 2 into 20, that is equal to 40 Newton. So 40 Newton is the force acting on the spherical body. 40 Newton is the force acting. Then here it is told a ball is projected with kinetic energy E at an angle of 60 degree with the horizontal. The kinetic energy of the ball at the highest point of its flight will be the highest point of its flight. What will be the kinetic energy? So here, if the initial velocity is u, then I can say half mu square, that is equal to e. So u square, therefore u square I can say that is equal to 2e by m. So u equal to root over 2e by m. Now therefore u cos theta will remain constant, u cos 60. This is the horizontal component and the vertical component is u sine 60. Now at the highest point, the velocity that it will have, it will be only u cos 60. Since why? The vertical component of the velocity will be 0 at the highest point. So now the kinetic energy at the highest point, of the flight. So that will be equal to half mv square, which is equal to half into m into v square. V is u cos 60, u cos 60 whole square. So that is equal to half m u square, and cos 60 is half, so half square. So that is equal to 1 by 4 times half mu square. Now half mu square is e, so it is e by 4. So e by 4. So option C is the correct answer. Then here it is told a bullet of mass 200 gram having initial kinetic energy 90 joule is shot inside a long swimming pool as shown. If its kinetic energy reduces to 40 joule within 1 second, the minimum length of the pool the bullet has to travel so that it completely comes to rest is kinetic energy reduces to this much in 1 second. Okay, so it means the mass is 0.2 kg. Therefore, the initial kinetic energy that is equal to half mu square, that is equal to 90 joule. So it means half into 0.2 into u square, that is 90. So this is 0.1. So u square will be equal to 90 by 0.1. So 900. So u will be equal to 30 meter per second. And similarly, V final kinetic energy that is equal to 40 joule, that is equal to half mv square. So therefore, half into 0.2 into v square, that is equal to 40. So v square will be equal to 400. So v equal to 20 meter per second. So it starts from u, that is 30 meter per second, and after here the final velocity is 20 meter per second at time t equal to 1 second, and it is at time t equal to 0 second. The minimum length of the pool, what should be the minimum length of the pool the bullet has to travel so that it completely comes to rest? So the final velocity v1 that should be equal to 0, then L should be how much, that is asked. So we know that v equal to u plus at. So therefore acceleration will be v minus u by t. So v is 20 minus u, that is 30, by t, that is 1. So it means it is minus 10 meter per second square. So it is the uniform retardation that is being caused by the swimming pool. So acceleration is this. So therefore, what should be the length of the pool? So we can say v square equal to v1 square equal to u square minus plus 2as. This s only you have to find out. S is the length of the pool. So therefore, s will be equal to v1 square minus u square by 2a. So v1 should be 0. 0 minus u square, u is 30, so 30 square by 2a, a is minus 10. So therefore it should be minus 900 by minus 20. 0, 0 cancel, so 245. So 45 meter should be the minimum length of the pool. Minimum length of the pool, so that the bullet will come to rest. 45 meters, so option A is the correct answer. Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter work, power, energy. So any doubts if you have, please write that in the comments section. We shall obviously clarify them. And in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comment section, so that we can give more priority on it and solve more and more questions on that chapter. Also, please install our Sapience Education application. Also, please install our Sapience Education application, where we shall upload some important previous year questions on JEE Mains, which shall be helpful for our exam. So here it is told sand is being dropped from a stationary dropper at the rate of 0.5 kg per second on a conveyor belt moving with a velocity of 5 meter per second. So one stationary dropper is there. So from there sand is coming out. Sand is poured at the rate of so dm by dt, I can say it is the mass which falls per second. So it is 0.5 kg per second on a conveyor belt. There is a conveyor belt. There is a conveyor belt which is moving, okay, with a velocity v of 5 meter per second. The power needed to keep the belt moving with the same velocity will be, so the power needed, that will be the sand is falling. So we know that power equals to dw by dt, where w is the work done. So work done is force into displacement, F into ds by dt, which is v. So it is F dot v. So here the force required, force will be equal to, force we know that is equal to dp by dt. So it is velocity is constant, so it will be v dm by dt. Your mass is getting increased. So v dm by dt. So I can say that therefore the power re required, that is equal to dm by dt into v. So that is into v square. So v square, v is 5. So 5 into 5 into dm by dt, that is 0.5. So this much watt. So it will be 25, 5. So it is 12.5 watt. Option D is the correct answer. So here it is told, as per the given figure, two blocks each of mass 250 gram are connected to a spring of spring constant K is 2 Newton per meter. If both are given velocity v in opposite directions, they are given velocity v in opposite directions, then maximum elongation. Second. So then the maximum elongation of the spring is maximum elongation of the spring is you have to find the maximum elongation. So here and velocity v in opposite directions. So here we can say that the so when there is maximum elongation, they should have a common velocity. So I will tell m plus m into v dash or v final, that will be equal to mv minus mv. Since v and minus v are their initial velocities. Here we are applying the conservation of momentum. So v final will be 0 only. When they will have so the final common velocity which they will have, that is 0 only when there is maximum elongation of the spring. When there is maximum elongation. So then therefore I can say that the the loss in kinetic energy equal to the gain in spring potential energy. It is half mv square plus half mv square. Half we can cancel, so x square, that will be equal to 2mv square by k. It means that will be 2 into m is 0.25, since 250 gram means 0.25 kg, into v square. V square by k. K is 2. So 2 will cancel. So x square is coming v square by 4. So x will be equal to v by 2. So v by 2 is the maximum elongation. So option B is the correct answer. Then here it is told a bag of sand of mass 9.8 kg is suspended by a rope. A bag of mass 9.8 kg is suspended by a rope. Suspended by a rope. Bullet of a bullet of mass 200 gram means its mass is so let's say this is capital M, this is small m, that is 0.2 kg. It is traveling with a speed u, which is equal to 110 meter per second. It gets embedded in it. Then loss of kinetic energy will be so if it gets embedded in it, they will move with a common velocity. Okay. They will move with a common velocity. So therefore I can tell the final common velocity, that let's say that is v final. So m plus m into v final, that is equal to mu plus m into 0, since the sandbag is at rest. Sandbag was initially at rest only. So therefore v final, that is equal to mu by m plus m. So that will be 0.2 into 10 by 9.8 plus 0.2. So this is also 10. So 10 and 10 will cancel. V final is 0.2 meter per second. So therefore the loss in kinetic energy loss in kinetic energy, that is kinetic energy initial of the system minus the final kinetic energy of the system. So kinetic energy system initially, that is half m u square minus this will be half m plus m into v square, v final square. So this will be half into m, that is 0.2 into u square means 10 square, minus half into m plus m, that is 10 into vf, that is 0.2 whole square. So this is 0.1, this is 0.04. So this will be 100 into 0.1, that is 10, minus this is half into 10 into 0.04, so 2 the 4, so 0.2, this will be 10 minus 0.2, that is 9.8 joule. So the loss of kinetic energy will be 9.8 joule. And here it is told a body of mass 0.5 kg travels on a straight line path with velocity v equal to 3x square plus 4 meter per second. The work done by the force during its displacement from x equal to 0 to x equal to 2 meter is. The mass of the body is 0.5 kg. Okay. The net work done by the force during its displacement from this x equal to 0 to x equal to 2. So work done by all forces, we know that is equal to change in kinetic energy by using the work energy theorem. So therefore work done by all forces, so it will be half mv square minus half m v final square minus half m v initial square. This will be half into m is 0.5 kg into v final square minus v initial square. So now v final means the velocity at x equal to 2 meter. So this will be 3 into 2 square plus 4, that is 3 4 are 12, 12 plus 4 16 meter per second. And v initial, that will be equal to velocity at x equal to 0. So it means that will be 3 into 0 square plus 4, that is 4 meter per second. So therefore the work done by all the forces, that will be equal to half into 0.5 means half only, and this is into 16 square minus 4 square. So this will be 1 by 4 into 16 minus 4, that is 12, into 16 plus 4, that is 20. So 4 3s are 12, 3 into 20, that is 60 joule. So 60 joule is the net work done by the force. Option B is the correct answer. Then here it is told in the given figure, the block of mass m is dropped from the point A. Block of mass m, small m, is dropped from the point A. The expression for the kinetic energy of the block when it reaches point B is. Hmm, yes, when it reaches point B is okay. Not. So uh, so we know that work done by gravity, here only gravity is acting. So work done by gravity will be equal to the change in kinetic energy. So work done by the gravity, to take it from A to B, that is equal to the change in kinetic energy, means kinetic energy at point B minus kinetic energy at point A. So mass is dropped from point A. So here initial velocity will be 0. So kinetic energy at point A will be 0 only. So kinetic energy at the point B that is being asked. So this is 0. So kinetic energy at the point B that is equal to work done by gravity from A to B. So gravity, the weight that is mg. So the work done that will be mg into y naught. Since the displacement from A to B is y naught only. So mg into y naught. So option D is the correct answer. And here it is told a particle of mass 500 gram is moving on a straight line. So its mass is 0.5 kg. It is moving with a velocity v, which is bx power 5 by 2. The work done by the net force, during its displacement from x equal to 0 to x equal to 4 meter is. So we know work done by net force equal to change in kinetic energy, which is according to the work energy theorem. So here, therefore, work done by the net force that will be equal to the final kinetic energy minus the initial kinetic energy. So now the initial kinetic energy means that is the kinetic energy means it is half mv initial square. So it means work done by net force that will be equal to half m v final square minus half m v initial square. Now v initial, it means the velocity at x equal to 0 meter, which will be equal to 0 only, since velocity is given as bx power 5 by 2. And similarly, the final velocity is the velocity at x equal to 4 meters. So that will be equal to b into, and the value of b has been also told, b equal to 0.25 per meter power 3 by 2 per second. Okay, so this will be b, that is 0.25 into x. X is 4 power 5 by 2. So this will be 0.25 means 1 by 4 only. 1 by 4 into 4 power 5 by 2. So 2 power 2. So this is 2 power 5. So therefore the final velocity that will be equal to 1 by 4 into 2 power 5. Now 2 power 5 is 4 8s are 32 by 4. So final velocity is 8 meter per second at when the particle will reach the point x equal to 4. Therefore, the work done by the net force. Okay. Yeah. Now, therefore, the work done by the net force that will be equal to half m into v final square minus v initial square. So half into m, mass is 0.5 kg. 0.5 into v final, that is 8 square minus v initial, that is 0. So this will be half into 1 by 2, since 0.5 is half only. 8 8 is 64. So 16 4 is 64. So 16 joule. 16 joule is the work done. Option D is the correct answer.